Hi, everyone. Thank you for coming to the Frost implementation update talk. I'm Natalie, and me and Conrado are engineers at the Zcash Foundation. We're going to be presenting to you today. So to start with, what is Frost? Frost stands for Flexible Round Optimized Schnorr Threshold. Try to say that 3 times fast. So we will call it Frost. This was designed by Chelsea Comlow and Ian Goldberg. This is a threshold digital signature scheme. So it's similar to multi-signatures, except that your key is split into n shares and for a threshold of value t, which is less than n. That can actually be the same. But for each, so t or more participants can generate a signature, and you never need to recreate the full key. So you only have a threshold of participants. And there are also defines 2 methods of key generation. So either with a trusted dealer or participants can generate the key shares amongst themselves using a distributed key generation method. And the advantage of this is a full key is never instantiated, which is great for security. So just to define a few roles, because we're going to be talking about this in the rest of the talk. So a coordinator is someone who chooses the message to be signed, which participants are going to be involved, so which has to be at least T participants, and generates the group signature. A participant is a recipient of a key share, so there will be N participants, and a signer is a participant that can participate in the signing of the message. So the sign has to be the number of signers has to be at least T. And if you're using a trusted dealer, then they handle the key generation. So currently the only way to do multi-sig-like signatures is on shielded ZEC. And multiple parties can create a wallet that requires T or more participants to sign a transaction. Signatures have the exact same format as regular signatures, so there are no changes required in the Zcash protocol, which is great. It does require some slight changes to the regular Frost protocol, turning it into re-randomized Frost. Signing is the same, simply requires randomizing the key before signing. So there are a variety of different uses of Frost for Zcash applications. So there's an example of a user having their keys managed by a shared custody service. And you can have you can have your shares backed up, basically. You can use it as a backup. So imagine if you lost a device, then you would be able to use the recover share functionality, which means that you're actually able to use your other shares to regenerate the share that has gone missing or been lost. And another way of using this is if you are in an organization or a group and you want to be able to say, okay, we want to be able to make transactions, but I don't want everyone to have to be there all the time. I'm happy if just 3 of you want to do it, and we're fine with that. So then your threshold will be 3. And yeah, next slide, please. Yes, so the Zcash Foundation version of Frost, we have implemented a Rust library, and it supports multiple cipher suites, these 5 listed here. As we mentioned, there are 2 different types of key generation, and we've implemented both of those. Signing, of course, recovering shares, which I just mentioned, and re-randomized Frost. There are additional Zcash cipher suites available in the Red DSA repository, which are Jub, and Palace.
Hi everyone, I'm Conrado. So to give some updates from last year's presentation, right? We did a presentation on ZconV. So since then, what's new regarding the protocol itself is that Frost was specified as a IETF RFC draft, which is still on the IETF pipeline, which is a bit long, but it's really close to final. And since last year, there were only editorial changes, just making things more precise and making the text clear. But the protocol itself has not changed since last year. And we also, Chelsea wrote a proof of security for the re-randomized variant of Frost, which is used by Zcash. And I helped her with the paper with the implementation part, and we published it on ePrint. So now we have more assurance that Frost worked correctly for Zcash. Regarding our crates, last year we were halfway through an audit, and this audit was finished. The report was published. They didn't find any major issues, and the issues that they did find were all addressed. We released a release candidate to gather feedback, to see if people were happy with the API. There were a couple of suggestions, and we also had some ideas of our own, so we did a bunch of refactorings to make the API clearer. And we did a stable 1.0.0 stable release of our crates. And also in the meantime, there was a denial of service vulnerability disclosed by Trail of Bits in the DKG process, not in the signing process. This impacted not only Frost, but several other threshold signature schemes. They were very helpful. They provided a test case to show that our code was vulnerable, and the fix was very simple, and the fix is already included in the stable release. Last year we presented a demo that showed how to sign Zcash transaction using Frost. But the way the demo worked, you had to copy pasting between coordinator participants. So since then we worked on adding online communication to make things easier. So the phase one of this process, we used the coordinator as a server and used raw socket communication between it and the clients. And then phase two, we chose to decouple the server from the coordinator. So now there's a separate server, which is a HTTP server that both coordinator and participants connect to. The reason for this is that people are usually behind firewall and ATs, and that makes it difficult for people to connect to each other over the internet, and this server helps with that. And ideally, we're still working on the server, but ideally the server won't be able to see the messages as are coming through. It just helps sending messages back and forth. So the architecture of the demo as it currently stands, it works like this. We use Y-Wallet because Y-Wallet supports like cold storage mode, where you can create a wallet with just a viewing key. And then when you create a transaction, it actually creates a transaction plan, which you can sign elsewhere, import it to a wallet, and broadcast to the blockchain. So instead of using the cold wallet signer from my wallet, we use Frost to sign the transaction. So the coordinator CLI will read the transaction plan, connect to the Frost server, and the participants will connect to it too. They will all run the Frost protocol, and the output of this will be a signed transaction, which you can import into Y-Wallet and broadcast. So back to Natalie.
Right, so what's next? These are the things that we're currently working on. So the first thing is we're going to expand the Frost server so it can be used to integrate Frost with wallets, and things we still have to do. So Conrado's already mentioned some things, and we also need user registration and other production level features. We also need encrypted and authenticated communication channels, pretty important, and client libraries. We're also working on refresh shares functionality. So the advantage of this is what you can do is you can actually remove a signer. So if you imagine that one of the shares was leaked, you're able to remove that. Also, if you're in an organization and then someone leaves, then you don't want them to still have access to, or still be able to sign transactions, but you're able to keep the same group public key. So you keep the same address, which is obviously great.
So how do we actually deploy Frost for Zcash? The hard thing is that there's no obvious way to do it. There are many possible options. Our suggestion is to use our Frost server. Of course, we still have to do some work on it, but when it's ready, we can use it. You can deploy the server like we have multiple Light Wallet servers. We could have multiple Frost servers, or maybe we could even ship them together. And using this server, one of or more of the Zcash wallets could add Frost support by using it. The main thing you need is like having something similar to iWallet, where you can create an account with just a full viewing key. It allows you to export the transaction plan and import a signed transaction. We talked about this in more detail in last year's presentation. You can check it for more details. We talk about how they work, what are the challenges, how the user interface work, and so on. And if you do that, we would enable that right side scenario that we showed of a shared wallet for an organization. But of course, even if a single person wants to use it, you could, if you have more than one device, you can also use this functionality. And we are open to collaboration, so if you're working on a Zcash wallet and you're interested in this, reach out to us in your GitHub or in Discord, so we can work together to actually deploy Frost. So another thing that's going on is the ZIP, so it's a Zcash improvement proposal that specifies how Frost is used with Zcash, because it's not super obvious. There are some things that you need to decide, so these are all written down in the ZIP. It's currently under review. Mostly the review has been just textual changes, make it clearer. What is described in the process of using Frost Zcash, I think it's basically done, and feedback is welcome. So if you have any feedback, you can post it on the Zips GitHub. So now it's demo time. So the way this demo works is that we have here multiple terminals, right? Everything for now is just on the command line, but maybe in the future we have an interface for this. So I will have 4 windows open. This first one will run the signing tool. It's just a tool that helps you interact with transactions. This here will be the Frost server. This here will be the coordinator, and these two will be 2 participants. So the first step is actually in my wallet. So I already created a Frost wallet here, but just to explain how I did it, in the signing tool I showed you, it allows you to create a Frost wallet. You import a group public key from a previously Frost wallet that you created. There's another tool to do trusted keychain or distributed keychain. So this tool will output you a unified full viewing key. And if you want to import that, you just go here and paste. I have a full viewing key just to show you how it looks like. You would paste the viewing key here and click import, and you will create this wallet that I already created before. I did this before because I had to send funds to it, wait for confirmation, so this is why I'm not doing it live. But after this process, you have your Frost wallet. But this, since it was created only with a viewing key, I can even show you this seed. There's no seed phrase, right? There's no secret material here. There's just a viewing key. So now let's create a transaction. So to test it, like last year, I'm going to make a post to Zack Pages, which is basically a messaging board powered by Zcash. So let's click here to create a transaction. This is Zack Pages address. I need to use a specific amount, which is .001 Zack, and a message. So live from ZconV, powered by Frost. So let's post that. I'll just click here. It will show me the summary of transaction, how much has been spent, what's the fee. And if I click here, Usually you would send a transaction, but since it's a full viewing key account, I can just save the transaction plan to a file. So I save this to the JSON file, and that's it. So let's go back to the demo. We can use the signing tool. So I'm inputting the transaction plan I just created, and the goal is to create this raw transaction here. I need the full viewing key that I have pasted here. And this will create a transaction and show me the SIG hash. So this is the hash of transaction, and this is the thing that is actually signed using Frost. And this is the randomizer, which is something particular to the Zcash protocol that is also needed. So let's do the Frost signing. Let's start the server. Usually, in a real scenario, this would be already be running somewhere, running locally, but you can I tested running on Google Cloud or wherever it works. You just have to point it to it. If you don't specify IP, you just connect to localhost, but I could pass a flag here with an IP or a host address and we'll connect there. So let's start the coordinator. So the coordinator read a previously generated wiki package and then asked me for the number of participants that will sign transaction. Let's put 2. And the coordinator connected to the server, created a signing session there, and got a session ID out of it. You can see a bunch of errors here. This is normal. This is just because the coordinator screened the server to see when the participants have completed their part of the protocol. This will be improved later. So let's go to the participant. So this is the first participant. You can see here by the key package 1. Let's paste the session ID. Again, the session ID back and forth will be streamlined. Eventually we'll have like an account mechanism in the server. But for now, the coordinator needs to send this session ID to the participants. So this is the first participant. And let's start up the second participant. Let's put the session ID and run it. So let's go back to the coordinator. The coordinator is asking me for the message to be signed. And like I explained, this is the SIG hash that was output from the signing tool, and also the randomizer. And now what magically happens is that the coordinator generated a signing package, sent it to the participants via the server. Each participant signed it, this hash, this message was received, and generated a signing share, a signature share. And both of them send the signature shares to the coordinator via the server. And the coordinator finally aggregates these and generates a final signature. So this is the final Frost signature that we generated, which has the exact same format as a regular Zcash signature. And we just go back and paste it to the signing tool. And that's it. It signed the transaction and saved it to a file. So now we can go back to my wallet, click here, and there's an option to broadcast the transaction. We click here to pick a file, select the raw file, and broadcast it. Took a bit longer, I was scared for a moment, but it worked. So here's the transaction ID of the transaction, and you can even see it in the block explorer. The transaction is out there. It needs to wait a little bit to be mined, and it needs some minutes to show up on Zack pages. You can check that later. But that's it. That's our demo. And like we mentioned, we're going to keep improving it so we can use it by wallets can use it. Let's go back to the slides. Oh, I have the pre-recorded demo here in case something went wrong. And that's it. If you have any questions, we can answer them. So the first question is, the demo currently supports a few participants, but is there no upper bound to the total threshold of participants? That's a great question. Protocol-wise, the upper bound is like whatever fits into a scalar, which is an implementation detail, but it's like a 2 to the 256. It's a gigantic number that you could never reach in practice. So in practice, the limit is whatever your computer or the server is configured to support. So we can make the upper bound as large as we need. I don't think people need more than, I don't know, 1,000, 10,000, but yeah, it's basically in practice doesn't have any concrete limit. Next question. Go ahead. Go ahead.
Right. One thing I will say is that T can equal N as well. So the threshold can be the same as the number of signers and participants.
Yeah, that's a good point. The threshold could be anything between 1 and N. Next question. What will it take for the demos to be used in a production environment? So the first thing we need to finish the server. So the server doesn't have encryption, doesn't have authentication, doesn't have any account management. So we need to add that. And when we have a production-ready server, I think people can, based on the demo code that we have, they will learn how to use the server. It's a very HTTP JSON server. It's very simple to interact with. And then wallets can, inspired by the demo code, they can integrate Frost by using the server. And of course, I think it's good to mention that this having a central server, if you can have multiple of them, it's not ideal. We view this like the first step to getting Frost deployed, but eventually we could work on a peer-to-peer solution to make wallets talk between themselves without having a server. This probably can has intersection. There's some proposals for Zcash to also have like some messaging mechanism in the Zcash protocol itself. So maybe that's one option to enable that. Next question. What client libraries are you currently working on? Which languages are targeting, and how can the community contribute to them? So for this server, like I mentioned, it's a JSON HTTP server. You don't actually need like a library. If you have a JSON and HTTP library, you can use it. But we might, of course, it's easier if you have something, right? Just functions that you can call without worrying about the inner details. And we can work on client libraries, but I think it's so simple that people can do their own using just HTTP and JSON. But now everything is Rust, but this could be done in any language. Next question. Are you planning to expand the contents of the Frost book to include more diagrams and details of how the protocol should be implemented, use it? Yes, I think this Frost book should be like the one-stop shop for learning how Frost works and how to use our crates. But we really need feedback from people from what do they need, what they want to see in the book. Because sometimes when working on it, it's kind of hard to take a step back and realize, what's missing, what's not. So if you have feedback on that, please send to us and we can improve the Frost book. I think that's it. Let's see. Let me check if it showed up on Zach pages. Sometimes it takes a while. Yeah, it's not there yet. Sorry. Sometimes it takes some minutes to show up, but hopefully you can see some things that I do while testing, but eventually it will show up here. And I think that's it. If there's no more questions, we can wrap up. Thank you, everyone.
Thank you.
Bye.